Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to our Thought Leaders series, Fast Track Your Plant Digital Twin. My name is Amanda and I will be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional owners of the land and recognises their continuing connection to land, waters and community. We pay our respects to their cultures and to elders, past, present and emerging. Before we get started, I'd like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, Bentley Systems. Bentley Systems is the leading global provider of software solutions to engineers, architects, geospatial professionals, constructors and owner-operators for the design, construction and operations of infrastructure. Bentley's microstation-based engineering and BIM applications and its digital twin cloud services advance the project delivery project-wise and the asset performance asset-wise of transportation and other public works, utilities, industrial and resources plants and commercial and institutional facilities. Today we will hear from 3 speakers followed by a live audience Q&A session. And I encourage you to send questions through to our speakers via the YouTube chat box during today's presentations. I'd like to welcome our first speaker for today, Andrew Burt. Andrew is Hatch's Enterprise Architect, leading the Digital Project Delivery Transformation Program, with a lead role in systems architecture design and strategic direction of their project delivery systems. He has over 25 years' experience in the engineering industry within Australia, Chile, North America and South Africa, with expertise specifically in engineering design and engineering, procurement and construction, management with EPCM systems, development and integration. Please join me in welcoming Andrew Burt.
Thanks very much, Amanda. Today I'd like to talk to you about digital project delivery and building a foundation for digital twins. So just to start off, what is the digital opportunity for the industrial asset lifecycle? It's a fairly large potential market size of around, as come out of recent studies, just under $800 million in 2020 or $27 to $28 billion by 2040 in terms of that market capital. Potential areas to improve the asset lifecycle include things like reduction of classical deliverables, streamlining our procurement processes, increasing wrench time in the field, so really improved efficiencies around the construction side of things, improving the handover with a much more seamless process to transitioning from the project through to the operations, enabling digital twins, of course, and then operational efficiencies that would come from having an integrated digital twin. So what is the definition of a digital twin? So a digital twin evolves through the engineering, procurement, construction phases and into operations. Really one of the goals is having a digital twin platform that can really simplify handover and ensure that no intelligent data that's built up during that project phase is lost. So 3 key areas of a digital twin, of course, is the digital representation. So that representation of the physical asset in a digital way, whether it be the complete asset, a unit process or a system. An important facet of maintaining a digital twin is that it is continuously updated. So making sure it's synchronized between all the sources of information and it's updated in parallel with physical changes in the field. And lastly, the digital twin should generate insights, whether that through the simulations, analytical or optimization capabilities, but the ability to use the information that's generated through the digital twin. Some examples of various digital twin services. There's all sorts of areas that digital twins can help an industrial asset. So whether it be augmented training, forecasting and what-if scenarios, assisting with remote expert support, operational guidance, performance management. safety barrier management, predictive maintenance and monitoring of anomalies and detection. All these things, along with the virtual plant immersive viewing, are all some of the examples of services that a digital twin can provide. So in order to build a digital twin, one of the cores, the core functionality that's needed is information management. And what are some of the information management fundamentals that go into building a digital twin? So firstly, you have to have a trusted source of information. That's a fundamental. Secondly, in order to aid the project and then into construction and commissioning and operations life cycles, a collaborative production process. So information is being generated by many different sources on a project, and making sure that the entire project team and extended project team have access to that information is paramount. The information has to be data-centric. It's not just about document-centric moving into the digital twin space. So it's not about traditional deliverables, it's about information, whether it be equipment lists, asset registers, information that's generated out of process simulation models, or content that comes from intelligent bills of materials from 3D models. It's all about that information that drives the process. Also, you need a continuous flow of information. So as that project is going through its life cycle, information is constantly being generated and renewed, and that entire information chain is paramount in getting it through the entire project group, so that it supports that entire asset life cycle. And one of the things that often comes up when we look at how we execute projects is it's all good to say this is the information we need, but making sure you get the right information at the right time. So information is delivered in just the right amount of completeness to support the particular life cycle or the particular phase of a project that it's in. So whether it be a feed project moving into execution or through into construction, commissioning, or operations, the information is maturing throughout that life cycle. It's important that the right information is generated at the right time and made available to the right people. From a sharing and transparency, we try to make sure that all the information that's generated on a project is available to be shared and exchanged. Of course, there is confidential information that is generated on a project, but even where that's the case, making sure that all the people who should see that data can see that data easily. So that transparency of ownership is a core fundamental of information management. As I mentioned, right information at the right time. So from an engineering perspective, there's all sorts of early information that's being generated, whether it's a basis of design, geotechnical work, calculations, drawings, documents, through into data sheets and models and specifications. All that information feeds downstream into the entire asset lifecycle. So making sure that that information is captured and made available through the contract and procurement strategies, that we're getting information back from our procurement supply chain, whether it be the performance characteristics of equipment or size and weight information to finalise design. All this information that needs to be made and available in a timely manner to support those all those different downstream use cases. And then that information, of course, then feeds through into the construction and commissioning phases, with information then coming back into the engineering models for things like as-built, as-installed information. And then finally, that entire life cycle of information feeds through into the commissioning processes. And then at that point, we're also adding in additional information, whether it be supplier details, spare parts lists, warranties, etc., along with the commissioning generating inspection reports and information that's generated throughout the commissioning process. And all of that information drives the final outcome, which is a fully data-rich operational asset. So how do we go about building a digital twin? Well, to start with, we have to build a digital asset. And the digital asset really starts back in the feed phase of a project or even before, making sure that we're doing The right information, we're capturing things like process design, optioneering studies, and that really early front-end design engineering and process analytics that's generating that early information set. That then flows on into the subsequent phases, into the engineering and 3D design and engineering phases of the project. That information needs to be captured in a way that's then usable for the rest of the project team for things like work packaging. So things like construction sequencing and project execution strategies, whether it be looking at commissioning sequencing and feeding that back through the construction phases and the construction planning to make sure that the engineering content is delivering in the right sequence to support both construction and commissioning and then finally operations. So all of that has to be able to be done seamlessly through that digital asset. Of course, a core area that we have to focus on as well is the project control side of a project. So how do we make sure we can monitor and control cost and trends and looking at the planning and scheduling side of the project as well, because that's a fundamental that, of course, needs to be maintained throughout the execution of the project to deliver the right outcomes for our clients when it comes to an operational asset. And then there's a lot of information that's generated through the materials management and contract administration phase. And making sure that we can capture that information is another major area of a project and its data set. So there's a lot of information that we would generate through the vendor supply processes, whether it be vendor data sheets or spares lists, detailed bills of material, but all of that information consolidates into the overall digital asset and that information set for the project. And one of the things that we've often had to look at is how do you go about those vendor processes? How do you move away from the traditional document-centric view and those interfaces with our vendors in terms of receiving and interacting with the vendors? How can we move to a more data-centric, model-centric approach to interfacing with the vendors and the entire supply chain? One of the areas that often is a gap is maybe not the suppliers, but the sub-suppliers. So how do we make sure that when we do our contracting strategies and we engage with our vendors early on in the project, what is expected in terms of delivery from a data-centric viewpoint? And then finally, when we're doing the planning of the project, the digital asset, at this stage, we've only got a digital asset. We haven't built anything. So now we need to take that information set and of course, go into the field and construct. We've got fabricators, we've got the contractors and construction teams in the field, and they're taking all that information. A core functionality as well that we've looked at in our digital asset strategy is a common data environment. This is where all that information that's generated through the previous phases of the project, through the engineering and procurement phases, are captured in that common data environment that can then be made available to the field, whether it be the construction team or the commissioning team beyond construction. And then there's other systems that start to get used as well. There's field management systems, there's work packaging, there's field control, and 4D simulation and control systems that are used once we get to the field. And all that information needs to be available for our construction management and field engineering teams. They're generating a lot of data as well, particularly teams like the commissioning team, who are generating punch lists and commissioning dossiers. All that information has to be fed back into that overall information set, because that's going to be important when it comes to handover into operations. All that information can be made available through not just the common data environment, but also through things like data-rich 3D and virtual reality portals. So visual asset viewing, you can certainly click on and use information through all of these data sets and make that information available to whether it be the field teams or even the home office teams, so that information is readily accessible in real time. And finally, now that we've actually built a digital asset, so we've got a digital asset, we've constructed our physical asset. Now we need to look at how do we actually move that into the operations and maintenance phase. So that's where you have this transfer of seamless data from the delivery phases into the operations phases. And ideally, you're doing that through a common data environment, and you're connecting the ability to connect that digital twin. So this is where you really get your connected plant. You're able then to associate plant control systems, SCADA systems, historians, with information that's been generated throughout the design, procurement, construction and commissioning phases. And that information can then be used for the operations team to do things like advanced process analytics. They can start looking at optimization, debottlenecking, all sorts of optimization and improvement studies that can be done around that information, along with improving the maintenance aspects. You do predictive maintenance with all of that information that's now being generated. In transitioning that information, we're moving from what's called the PIM, or the Project Information Model, to the Asset Information Model, or the AIM. These are terms that have been, I guess, polarised in the ISO 9650 standard that came out of the original British BS 1192 standards that was used predominantly in the infrastructure space. This ISO standard is now globally accessible. It's being built on all the time with new parts coming out. But one of the primary areas it does talk about is this transition of the PIM to the AIM. In other words, that project information model to that asset information model through a continuous handover approach. And in even dealing with the project side, it's how you're dealing with all the various parties that are part of a project. So the design integration, the production of project deliverables, dashboards and information, how do you deal with construction, and how do you deal with the change management aspects as well. Some of these basic frameworks are outlined in ISO 19650, but a lot of that has to be also implemented by the engineering and project teams as well, using ISO 19650 as a basic framework for how you interface across parties on a project. And then what that looks like as it transitions into the asset information model, or the AIM. So from a digital delivery technology point of view, what do you require? Digital delivery requires a digital foundation. You've got to have the right foundation to support the people, the processes and the tools that power project execution. So some of the things, of course, those key areas of digital delivery is our people. So change management. How do you implement change and transform your business in a digital way? One of the core things to make sure that you do is focus on the change management aspect itself. So go and engage with, of course, the people, but make sure that they're on the journey. They have to be part of understanding that moving to a digital delivery approach is a mindset change. It requires, right through that entire life cycle of the project, that you're going to be changing the way that you plan the project, the way that you interface with your external parties, consultants, vendors, etc. Contracting strategies may need to be revisited. And from a client's perspective, the client deliverables and their handover could potentially be different as well. And making sure that the project team themselves are aware of what that means to their project is certainly a fundamental. Processes. There's a lot of processes that we use on all of our projects, but it's important that those processes are reevaluated to make sure that they're getting the most out of the technologies. Fitting a new technology to an old process may not be the best approach, but understanding the old process certainly is a starting point for improving and reinventing that process in the future. So looking at how do you optimise those processes using modern technologies is a core area to also improve. Looking at the application side, there's many ways to design applications in these days. There's all sorts of new technologies. There's mobile, there's cloud, etc., which I'll talk about a little bit further on. But there's certainly a lot of new ways and new technology approaches that can be looked at from a systems and tools point of view. And another core area is the data. Really putting a premium on the data. And one of the things that we're often reminding our project teams about is that the data is becoming a core part of the deliverable. So when we say the project deliverables, we're not just talking documents and drawings. The data is actually one of those core areas that we're delivering to our clients, particularly where they want a digital twin. So you need a digital foundation. You need to look at your infrastructure. You need consistent, robust infrastructure to deliver these sorts of projects. You need a consistent operation. You need to look at who is actually providing these platforms, and security is paramount. Certainly, one of the things that I'm sure everybody's aware of is internet security, and making sure that everything that we do is secure from an IP point of view, whether it's from a client point of view, but certainly building in from the starting point, the security aspects of any platform is a fundamental in systems design for a digital delivery project. So one of the things I guess that's also changed over the number of years is our project landscape. This is just an example here of one particular project that we have in Hatch. It's just a complex major project that's being executed with a project team in Canada, and there's parties on that project that are all over the world. Now, a number of years ago, we used to see this as being probably more the exception. We had major projects that might have looked like this, but a lot of our smaller projects may have been executed out of one location. You might have had equipment suppliers out of one other location, but generally a lot of the engineering, consulting, and specialist knowledge was in single areas or not very dispersed at all. But now we're seeing that this project landscape is more the norm. Even some of our smaller projects in Hatch are still executing globally, utilising specialist skills and information where it resides. So, as I said, this example shows that we've got client teams and specialist engineers, software vendors, suppliers distributed all around the world. So, to support that, we also have one of the other angles to consider in this digital platform is just starting by data-centric engineering. All the information that we generate, things like our drawings, all of the models that we generate, there'll be information that's in Excel spreadsheets, that's in databases. We have information in tools like Bentley's ProjectWise or Autodesk's BIM 360 or Hexagon SmartPlan. All of these tools contain significant amounts of information about the project. And all that information needs to feed into that common data environment that I introduced earlier. So things like our delivery, we've got deliverables, we've got design data, and we've got data itself, things like equipment lists, bills of materials, etc. And that's then producing a lot of information, or there's a lot of information in those repositories, things like our documents, drawings, data. We need to do work packaging as is one of the core approaches to executing a major project. We're doing analysis and intelligent modelling, and we're integrating vendor data as an example. Now, some of the basic functions that you want to get out of that is how do you have collaborative workflows? How do you provide that distributed engineering and broader consulting team to see and use all that information collaboratively to get the most out of the platforms that are available? How do you make data accessible? And there's a couple of obviously new technologies, things like virtual reviews. VR is becoming much more prominent. People liking to access not just the 3D model, but also the information contained within the 3D model in that immersive VR environment. And then we've also got technologies like web design review, moving away from the traditional desktop applications with a high amount of administration and data processing, but really providing that real-time access to the design engineering space and making it readily available across the world in real time to support that distributed workforce. But that then branches out into the whole of the project. We've only really talked about the engineering side on the previous slide, but what about the rest of the project? So we've got the construction, the commissioning, the project controls, and the procurement teams that are generating all that other information as well, whether it be construction planning information or GIS data. It's commissioning information in tools like Omega and others, Primavera P6 schedules, might be tools like Hexagon Smart Materials that's being used for procurement. But there's a lot of information that's been generated outside of that engineering space that also forms that body of information that we need to capture and integrate. And that's then feeding a lot of other, those same repositories that information is being collected in. So it still comes down to deliverables and design information and data. We then have to bring that together into things like reporting, supporting the procurement processes. There's project management and controls to monitor and control the job, and then, of course, the construction and commissioning. And then some of the features that you may want to get out of that is things like, the data management side and reporting. So providing information, whether it be cost trends, material quantity trends, earned value analysis, all the information that you're producing can be used to drive those real-time dashboards to give better insight to the health of the project and the state of the project. Making sure that broader engineering team and that broader project team have access to all the information that they need to do their job is certainly a fundamental. And embedding things like advanced work packaging in the methodology, whether that be around construction work packaging, commissioning system packages, procurement packages, engineering packages. All of those packages drive the execution of these major projects. And having a lot of information, making it readily accessible, and some of the things we can look at with the technologies available is things like search. There's some very powerful search engines out there that can be used to bring this information together and make it much easier for the broader project team to gain access to the information that they're after. So I won't spend too much time on this, but just to show you from a digital platform point of view, this is the approach that we've taken at Hatch. But really a modern digital platform may look nothing like what we have in the past. We've got new technologies from companies like Microsoft Azure, Amazon's AWS, etc., where you have these very powerful cloud platforms that can deliver a lot of integration and can really be used to house a lot of that content that you're generating throughout your project. And you can add services and use that information if and when the time's right. Certainly one of the things that we're finding at Hatch is that the technology alone isn't usually the stumbling block to getting something done. For the most part, the digital technologies that are available these days can do almost everything you can consider, and they're improving all the time. So, generating and capturing information in a platform that can grow with the business and grow with the evolution of digital twins in general and the industry is certainly something that we should all be considering. So just one of the areas, and you'll you'll see more about this from our Bentley presentation that's going to follow, is tools like Bentley's iTwin. It provides a platform-independent 3D model hosted in the cloud. We're able to use that to generate web design reviews, to drive 4D construction simulation, streaming virtual reality environments, tools like PlantSight, which will be presented by Patrick very shortly. All of these web-enabled tools are driven off the same independent cloud hosted model that can interface with all the different software vendors that most of us use to execute our projects, whether that be from Bentley, Siemens, Aviva, Hexagon, Autodesk, or anybody else out there. They certainly interface with most of those major vendors, or nearly all those major formats of files that we encounter. And some of the basic features, of course, that we use that drives the project are things like issue resolution, being able to manage punch lists and holds on projects related to design, running simulations, comparison of model and data information, running design validation, enabling work packaging that I've mentioned previously, and then the integration of data and documents along with the integration of operational systems. So that Bentley iTwin for us is a huge enabler in moving to that digital asset to digital twin strategy. And then finally, from an Azure point of view, we're been able to work with the Microsofts and the Bentleys of the world to look at what can the Azure services provide around digital twins. They have a lot of functionality, whether it be from using their IoT information, their edge devices, allowing us to connect sensors from the field back into that Azure platform, capturing information from a time series point of view, so you can actually look at historical data and chart trends, and then presenting those in a real-time visualization with tools like iTwin. This is just a couple of screenshots here of some examples, but on the left here you'll see this is the Azure Digital Twin Explorer, showing some of the equipment and sensors that are collecting information from the field, and then using those to present them and then color code them and highlight them as certain process conditions or criteria has been met, whether it be exceeding temperatures or low flow rates or whatever you might put in place in order to monitor that piece of equipment. You can link that information between that Azure digital twin and the iTwin visualization. And that's all I have. So thank you very much for the opportunity, and I'll now hand back to Amanda.
Thank you, Andrew, for your insights. I'd now like to welcome our next presenters, Maureen Gervais and Patrick Wickie. Maureen is the Digital Integrator Business Development for PlantSight at Bentley Systems. She has over 18 years of diversified experience designing, architecting, and developing software products for the plant domain. In Maureen's present role, she works closely with users to reimagine their existing workflows and interactions to deliver maximum impact and value while leveraging iTwin, digital twin technologies. Patrick Wickie is the Business Execution Manager for Facilities Engineering at Bentley Systems, managing a team of product specialists in the Asia-Pacific region and ensuring successful adoption and growth of Bentley's plant design solution. Patrick has over 20 years of diverse experience in process project engineering and the deployment of the software used from conceptual through to detailed design. Please welcome Maureen Gervais and Patrick Wickie.
Thanks, Amanda. Hello everybody and welcome to our session today. Fast track your plant digital twin with focus on engineering collaboration. Bentley is a leader in providing software solutions for infrastructure professionals. Bentley's open, distributed and federated approach to ingesting and integrating underlying source data to create functional digital twin is unique. Today we will talk a lot about PlantSight. So what is PlantSight? PlantSight is a set of cloud-based services that help you visualize data and models over the entire asset lifecycle to validate information, ensure compliance, gain insights, and make fast and accurate decisions. In all projects, data is being handed over in different formats during different stages of the project. Using digital twin workflows, users can make better decisions for a better outcome. One of the key benefits of PlantSight actually is the highly simplified, if not elimination, of the handover process. For instance, from the design stage to operations. During today's presentation, we are focusing on the design and engineering stage. However, Bentley's digital twin solution does also provide services for the other workflows, such as construction, operations and maintenance, etc. It is fundamental for an efficient digital twin solution to ensure that getting information from different sources and keep them updated automatically for an evergreen digital twin is simple and comprehensive. For that, Bentley has developed connectors for a wide range of applications, whether from Bentley or third party. There is no vendor lock. Bentley does listen to its clients and continuously develops new connectors. For example, in Australia, particularly the West Coast, the addition of a Navisworks connector has been requested by multiple users and is now available. These connectors and related PlantSight services help to significantly reduce the time you typically spend transforming and integrating the data coming from different design applications. Users can contribute digital engineering models without any change to existing applications or formats, allowing organizations to take advantage of this platform with no disruption to existing workflows. By the way, this slide only shows a selection of supported application and interchange formats. I'm happy to provide a link to a website listing a complete list. Now, if I'm not wrong, Marine, besides that, we can also bring in reality models into the digital twin.
Yes, Patrick, and that can really liven up the digital twin experience and put your twin in that real world context. Here is a mining extension that one of our users is working on for their clients. All in a single view, they can get the visual real world context from maps and laser scans, and the engineering context with no vendor lock-in. They can now bring in and visualize together engineering models from Bentley Open Plant Modeler, ProStructures, from Navisworks, IFC. This allows data discovery, review, and the ability to extract insights across the multidiscipline design. They can easily section data and highlight parts of the model and share them with their team. One of the biggest challenges on such a large project is finding accurate information in a timely manner, and accessibility and accountability. We know if you have access to design information over time, it improves the veracity of the data and ensures that people have access to up-to-date and trusted information. So with PlantSight, we're not only able to visualize the information, but also interrogate the data-rich digital twin of the entire facility. They can find information easily based on engineering attributes, fast searches across the entire model, and they can also access all the engineering attributes and graphical data hosted in a scalable and secure cloud environment. And this really democratizes access to the engineering information across distributed teams. Our Bentley design tools have a bidirectional integration with PlantSight, and this enables data-driven engineering design workflows. And now I'll hand it over back to you, Patrick, to share with us the details.
Thanks, Marine. Yes, indeed, Bentley design applications do bring some key advantages to the table when collaborating with our digital twin solution to further increase productivity. Let's have a look at a possible solution diagram. So first, we got a PlantSight entity, a cloud-based digital twin solution. As previously stated, there are a wide range of connectors available that enable the acquisition and aggregation of engineering models and their related data from multiple sources. Bentley design apps are equipped with additional digital twin collaboration capabilities, such as referencing or access the project's issues registry, which Maureen will further explain later. Here, a possible use case on referencing, for instance, a Revit model had been pushed to plant site, could be easily referenced into, say, open buildings without the need to worry about file format conversions, etc. OpenPlant, Bentley's own 2D and 3D multidiscipline plant design software, is capable to sync data directly into plant site as well as read the relevant information back into the design. It forms the basis of consistent data usage between OpenPlant applications, avoiding costly rework for removing inconsistencies in data and deliverables down the line. The PlantSite portal provides a cloud-based one-stop shop for visualization and management of tags for OpenPlant workflows. It provides real-time visualization of all changes with relevant data information and allows cross-probing between P&IDs and 3D. Finally, OpenPlant's deliverable tools to generate deliverables such as isometric drawings right from the source with no need to open a design file. Let me show quickly a workflow how a new asset tag, for instance, a pump, is created in the cloud environment and then placed on a P&ID in the 3D model and finally reviewed in plant site. So here what I have, plant site, showing you the data environment, going to the data manager. And in here I can go and create new tags, which I'm going to do here. Go to the pump menu and enter all the necessary information for a new pump tag. Once I've done this, I can go and say add to plant site, which is kind of in between stage. I can still review and apply further changes. Once I save this tag, it's available for everybody else to use. So in this case, I'm going now into the P&ID design environment, OpenPlant P&ID, and I want to place this pump into the P&ID design. For that, I'm going to browse plant site, and here we go. Here's our tag that we just created in the cloud environment. Place the pump and then sync that information back to plant site. It will show us a differencing dialog, again, for us to review what has changed since the last sync, and then the sync is completed. Now let's go to the 3D design environment, and here now I can place the same pump using our consistency manager. Here in OpenPlant Modeler, just going to quickly query the plant site data source. It will show me all the data and tags that are available to be placed in the 3D model. Browse here into the pump, and here we go. Here's our pump that we just placed in the P&D. I can see that by this icon there. If I click on the heat exchanger, we can see the two icons. That means they're placed in 2D and 3D. So let's now place this pump here into the 3D space, and we will immediately get the 2D 3D consistency enabled. Here also, let's go and sync this change back to plant site. And again, we get the differencing dialog where we can check what has changed since the last sync and apply and commit the change back to plant site. So very simple process to use the data in 2D and 3D and sync that always back to our central repository. Or we could call it actually master tag registry. Before going back to plant site, here's another feature how we collaborate with our digital twin. And these features here are available with all the Bentley applications, not just OpenPlant. I can, in this case, access the issues registry, which Maureen is going to show you more details. I can reference information from the digital twin, etc. Back into the cloud, if you like, plant site, I go now into the visualize section. And here I can see the pump has been placed. I have this little window where I can see the P&ID. If I click on a pump, it will automatically zoom into the corresponding pump in the P&ID and will show me all the property information related. For instance, if I click, just to show that cross-probing again, click on the tower, it also will open a different P&ID in this case and zoom in and show all the relevant data. So Placing a pump might be easy, but you need approval from all stakeholders, and therefore design collaboration is key.
Yes, Patrick, that is key. Design collaboration using integrated design workflows with PlantSight allows you to run clash detection now across all of your engineering data, regardless of the source format, collaboratively and more effectively in the cloud. It basically eliminates the limitations of local files, as one of our users told us that issues that are not found during design arise when construction begins and can be very costly for the project. Now, with PlantSight, you do not have to wait for a project milestone to validate your deliverables. You can have ad hoc design reviews on up-to-date engineering information, ensuring consistent, complete, and correct engineering data at all times. Also, with our integrated issue management services, you now have an optimized and tighter feedback loop throughout your project for better decision making. This automatically leads to improvements in team productivity and also the quality of designs. Let me show you how easy it is to run clash detection checks and manage issues in PlantSight. With PlantSight, people can simultaneously work on a single view and always have access to latest and approved designs. Over here, I have run a clash test on 2 different versions of the project. Some structural changes were made, and as you can see, some new clashes have been introduced. Looking at the clash reports, comparing them, I can see the new clashes in the report. I can visualize these results in the context of the 3D model, giving me more insight on where the clash is and how to rectify it. Clicking on one of the clashes, I can see it automatically zoom into and highlight the clashing components. I can see that one of the clashing components, the beam, appears in 2 clashes. I can group them together and directly from the interface, without leaving the application, create an issue. The issue records all of the details of the issue that's found that needs to be shared with the engineers. It has information about all the clients. You can create markups. You have a complete audit trail of all the information that was captured. You also at all times have access to all the attribute information, and you can see who the designer was, when this change was made, what the attributes are. Also, with the integrated issue management service and dashboards, we've eliminated the limitations of email communication, especially on larger teams. PlantSight issue management capabilities, they really reduce management costs and overheads to a considerable degree. Over here, you see a complete audit trail of all the communication that happened across the issue. You can add comments, you can add more information for your teams to make better decisions as they rectify these problems. All the communication is now captured as part of the project. Now, with PlantSight, you not only have a timeline of change and historical data of your engineering design, but capturing all the decisions communication that has happened over the project. With PlantSight, we now, of course, we're able to improve collaboration across distributed teams and contractors. But this does not only apply to the design phase, but also in the production process and in later stages of the project lifecycle. So, Patrick, we were talking to a company that was dealing with such a situation. Can you tell us more about how companies are dealing with production taking place in another country when they cannot be there?
Yes, Marine. As PlantSight is cloud-based, the data is accessible anywhere at any time. And with the connectors, as mentioned earlier, we're not only pushing graphical data into the digital twin, but also their related property data. Here I'm showing just some examples how to use that data in PlantSight. The simplicity to keep the data up to date, plus the fact that we are tracking all changes coming into the digital twin, opens up many opportunities to gain a lot of value from the digital twin. So as a use case, I'd like to show you where an engineering firm is fabricating their pipe spools in a different country and how they can involve the fabricator to update information, for example, shipment status or fabrication status to the components, allowing the engineering firm to get real-time updates on what's actually happening in production. So let me show you this scenario where an engineering firm was actually in Europe and the fabrication happened in China. So in this case, we instead going to the visual part, we're going to go into the data environment of PlantSight. And the query section in PlantSight is there not just for open plant data, as I shown you before with the data manager. Here I can query everything coming into the digital twin. So here got my pipeline query where I can see the status. So the fabricator can go here and update those status values. And the engineering firm in a different country would immediately see those changes that the fabricator has added, and then can use that data for, in this case, we go into the visualizer to visualize what happened in a certain stage of a project. So here I'm in the visualizer of PlantSight, and I can, on the left side in the breakdown structure, I can browse all the pipelines, but I can go and actually highlight what has changed when by querying the status property. So here I can go and first hide all the property stages, and then select a particular property stage status. So what happened in a particular date, it will highlight that in color, as you can see in the visualizer. So this way I can easily keep track on what's actually happening in a total different place in the world by having the fabricator, in this case, using the same data source. Another feature that we have here in PlantSight is to compare actual versions. So I can actually see what happened in a particular time frame. So in this case, I just check what happened from last week to now, and I can see that also then in color code. Additional to just see what graphically has changed, maybe something has been moved, deleted, or added. I can also compare actual property changes, like in this case, the status has changed for this particular component. So this is adding quite a lot of value. So what we have seen in the video or in that demo is just one scenario how to make use of the data in PlantSight. The capability to query any data in the digital twin is adding a lot of value and opportunities. In particular, I like the fact that the query language is very similar to SQL. There's so many ways to query data, and it is quite easy to find information online too, which is helpful. The example here is just, the example that I'm showing here is counting how many valves there are of a specific type in a project. So counting the number. To create this query enabled the advanced mode, which allows me to write a select statement as if it would be a SQL database. So that's enough technical stuff. So let's now talk more about what else we can do with PlantSight. Marine, there is so much intelligence in this digital twin that there must be a huge competitive advantage for any engineering design company.
Yeah, absolutely, Patrick. You're absolutely right. Digital twin is a hot topic at the moment, and engineering firms are seeing a significant business benefit. The beauty of the digital twin is that whatever was built in the engineering phase can be now handed over to the owner to be further integrated with other operational systems such as SAP, ERP, plant maintenance, and analytics systems. A major challenge that our users previously had was that it took way too long to find information, and worse, when there was a change, a modification, or an addition to an asset, it took way too long to update all of the other systems that needed to know about that change. With PlantSight's digital twin approach for the entire asset lifecycle, we basically eliminate disconnected data in a plant. It enables a system of systems approach, helping engineers to gain insights and envision engineering designs required for sustainability, resilience, adaptability to keep the plant profitable and compliant. And now let's look at some use cases in operations. PlantSight's digital twin allows you to visualize and analyze asset performance to make better decisions in your plants anywhere in the world. What differentiates the Bentley solution is that it converges and connects data from engineering, operations, and maintenance. It empowers people with the situational intelligence needed to minimize risk and cost, maximize safety, and optimize production. Here we see a streaming view of 4D analytics showing what is going on in the plant. Now let's take a closer look at the model view of the digital twin to see what's happening in the plant. In PlantSight, you eliminate disconnected data, and it makes it easy to build a digital twin and access all of the multidiscipline engineering data alongside operations, keeping it up to date in the digital twin. This model was designed primarily with Hexagon SmartPlant 3D tool, In many operating plants, there may not be a 3D model at all. Here in this plant, this pipe rack was added later. So it was not included in the original design models that were handed over from the contractor. With Bentley's reality modeling software, we can capture high-resolution photographs and quickly create a photorealistic reality mesh and include it in the digital twin. Now let's look at the alarms. Here we see the assets that need our attention. Before acknowledging the alarm, let's dig deeper into the twin to find out where this asset is, what actually caused the problem, and decide if it's time for an intervention. In the digital twin, we visualize everything in the context of where the asset is. We see the alarm information, the reliability information at the bottom. In a convenient picture-in-picture view, we have the piping and instrumentation drawing. We see the full system and understand that there is a second pump in the circuit that could also be a looming failure. Engineers basically need to avoid and mitigate the consequences of a complete system outage. They can see which pumps, how to isolate the pump, what valves in which lines need to be shut off. We also have access to real-time performance data for the pump. Information is aggregated from many sources, for example, IoT sensor data, edge devices, data historians. These communicate with the digital twin cloud service based on industry standards for interoperability. So no matter which system you're using, we're able to integrate it into plant site using our enterprise connectors. Now teams, based on this information, can take better decisions for their plants, and for them, time to decision is key. And for with plant site, they know for certain that they're always accessing accurate in a living digital twin when and wherever they need it. Next, I want to share a case study of how Hatch set an industry standard by reducing production ramp-up time from 6 months down to just 1 week on their new sulfuric acid plant in the remote region of Democratic Republic of Congo. They used Bentley applications, and using them, they were able to optimize engineering quality and project delivery. And here is a story of how they did it.
The Hatch sulfuric acid plant project is a great example of delivering a best-in-class process industry digital twin today. Hatch leveraged the digital twin to create a process manufacturing plant in the Democratic Republic of the Congo. They were able to deliver the plant in under 2 years from feasibility to startup. The team developed alternative procurement strategies to lower the cost of material supply in this remote region and cut months from the schedule. By deploying a constantly up-to-date digital twin throughout the entire project, when it came to commissioning, Hatch was able to reduce production ramp-up time from 6 months to just 1 week.
Hatch was an early adopter of 3D design processes and data-centric digital delivery concepts. And we were able to see the value that those ideas and those processes brought our projects. Obviously, there was an immediate improvement in engineering efficiency. But importantly, we were able to deliver our projects with shorter schedules, which brought even more value to our clients. We were able to bring the data-centric processes to the construction space. Importantly, we saw rework values that were extremely low due to the fact that we were able to virtually build the plant in the 3D environment. What is next for us is the digital twin, and we're going to be bringing all of that important information through engineering, construction, commissioning, and into operations. The digital twin is the next step in our digital journey. PlantSight is a fantastic product that will enable us to deliver the digital twin to our clients and their operations. One of the biggest benefits of a tool like PlantSight is the complete elimination of the handover process. Typically, at the end of a project, we hand over documents, data, drawings, electronic files that typically our clients really struggle to understand and use efficiently. PlantSight is a tremendous platform to get that information in the operator's hands when they need it, to make good decisions in a timely manner, and to operate their assets at a higher level of efficiency. But we believe the value of digital project delivery is actually proven. We've been able to demonstrate that projects can be delivered with a higher level of efficiency, lower rework, and shorter schedules, and lower cost to our clients. We have numerous examples where digital project delivery has been able to enable that. But what is next for our clients is the digital twin. And all of our clients are looking for that powerful tool to enable them to operate their facilities using that rich data sets. Digital twins are in demand, and all of our clients are looking for the types of solutions that will take them to that next level of efficiency. Digital project delivery brings great benefit to our projects in addition to the schedule compression that we talked of. In typically lower rework rates in the construction space, we're able to actually virtually build the plant in the office. We can package the work as efficiently as we can to allow our contractors to be as productive as possible. We can do early collaboration, get as much input as possible in the model space, and as a result, we have a shorter schedule and a lower cost that can be done safely. The future of efficient plant operations is going to be centered around digital twins. PlantSight is a tremendous opportunity to capture value that can't be captured today.
So in summary, PlantSight is first and foremost a new cloud service leveraging a Microsoft Azure that enables data-centric digital workflows. It introduces a live and current infrastructure model in the cloud, allows for alignment, enabling for the first time change management, empowering you to realize the value of your data, gain insights, and make more informed decisions. And above all, the data is easy to find and accessible from anywhere at any time. Thank you for your time. We hope that this was an informative presentation for you, and I will now give it back to Amanda.
Hi. It's now time for you to get involved. A big thank you to our speakers this afternoon. And please, it's your opportunity to ask questions to our speakers, so please send them through to us via the chat box. Unfortunately, Andrew is unable to join our Q&A session this afternoon due to unavoidable issues, and he does send his apologies. So if you could please send your question through to Maureen and/or Andrew and/or Patrick via the chat box. Please ensure you provide your name and who the question is for. We did receive some questions on registration. We'll begin with those, and thank you for those that sent those through. Maureen, I might actually start with you. We've had a question that's come in from Nelson, and Nelson is watching from Victoria. Good afternoon, Nelson. And Nelson's question is, can you explain how to manage delegations of authority, ensuring approvals are only conducted by authorised individuals? Maureen.
Thanks, Amanda, and thanks, Nelson, for your question. So in our iTwin platform, and since PlantSight is based on the same platform, we do have extensive role-based access control and user management that allows you to control permissions at a very granular level. So you can ensure that people who require access to information or certain features are given that access both within your organization and external to your organization. So if you invite clients or stakeholders, you can control what they can see and what they can do within the application. And that is also applicable to your review workflows using issue management.
Thank you, Maureen. Patrick, over to you. We've had a question that's come in from Nicholas, and Nicholas is watching from Queensland, asking you, how do you create a digital twin of complicated systems with dynamics that aren't directly measurable? For example, belt tension in an overland conveyor. Thanks, Patrick.
Yeah, thanks, Amanda, and thanks, Nicholas, for the question. So, okay, conveyor belt tension. So this is actually more sort of a operations questions, for which, by the way, we do have a subsequent webinar where we go more in depth into this kind of topic. However, from what I understand, what we would usually take is the thickness of the belt, some load data and speed, etc. And that's kind of a combination of online and offline data. So like online data could be coming from sources like SCADA, so where we get some information by load sensors at given points. That will give some idea what's happening. So combine this with some offline data, maybe from inspections on the belt thickness. I think that would be probably the way we would tackle that. But again, this is probably going to be covered more on the next webinar. But yeah, that would probably cover this question. I hope it's answered the way it should be.
Thanks, Patrick. I've got a question that I might start directed to you, Maureen, first, and then you might want to pick it up as well, Patrick. It's coming from Lawai, who's based in New South Wales, asking, what is the difference between digital twin and BIM technology? And maybe we'll start with you, Maureen, and then go over to Patrick for his views.
So what was missing in BIM was context and chronology. And now with the ability to survey what is already there in the field in a matter of hours and days, you get a reliability mesh with engineering precision, and also the ability to federate change and converge information from 3 sources, ET, IT, OT systems. That's what makes the digital twin more useful, and also provides the ability to manage your information flow and not just focus on deliverables.
Thanks,
Yes, I
Maureen.
agree. Sorry, Amanda.
No,
So
Patrick, you're good.
So yes, I agree. So I think that's a question that we are asked quite often. So I would say BIM could be seen as a information source to feed the digital twin. So one of the many, maybe. So benefits of BIM are there. I mean, it's the reuse of intelligence created in the design and construction phases. And then making that easily available to stakeholders later in the much longer operations and maintenance phase. So that will then deliver the return of investment. And that's then the part of the digital twin on top of what BIM typically does. So that would be our answer for this.
Thank you for that. Thanks to both of you. Over to WA, and a question for you, Maureen, that's come in asking from Craig. Good afternoon to you, Craig. I think it's still, or good morning in WA, asking, can the review process be integrated into the verification of the construction? Thanks, Maureen.
Yes, it most certainly can. So construction workflows, especially in our Bentley Synchro products, are supported by the issue management service that's available in our web, desktop, as well as field products for offline access. So you can actually access your digital twin, create issues directly in the field, and when you have internet access, you can synchronize those back to your digital twin environment. So yes, your issue management and your review workflows, all of those are available as you construct your assets.
Thanks, Maureen, for that. And staying in the West, and over to you, Patrick, we have a question from Trevor asking, what are the challenges with using real-time data, equipment performance, production data to develop predictive user cases? Thanks, Patrick.
Okay, thanks, Amanda, and thanks to the question. So yeah, another question more for the operations point of view, which again we will cover in a subsequent webinar. So my understanding here is the challenge is if we use the mathematical modeling, as it called, from historical data, that's kind of the traditional way, gives some good predictions just for a short time, maybe not enough to send someone on site to replace or fix the issue. So what we have seen to improve this is by adding some reliability modeling to this that will extend the prediction time frame for an accurate prediction, and that's one of the benefits I think with our solution. And again, I have to point to our experts on the operations, which will be in a subsequent webinar coming soon.
Thanks, Patrick. Maureen, do you want to comment on that as well?
Yeah. So as Patrick mentioned, the ability to bring in your operational data into a digital twin is a key capability, and it certainly adds value as you hand over information, especially if you're an EPC and you hand over information to operations for the owner operator to optimize their maintenance workflow. So yes, and as Patrick mentioned, we'll cover that in a subsequent webinar.
Thanks, Maureen, for your views there. We've had a question come in directed to you, Patrick, asking about compatibility and asking one of the main issues always is compatibility of the data generated by several providers. How is this an issue and how can this be managed during integration? Thanks, Patrick.
Always been an issue all my life in this business. How to bring this stuff, this content together, how to make use of it, etc. So certainly it all depends on what the use case, what I want to do with all this information coming from different providers. So with this digital twin, what we've shown with plant side as an example, it has been made quite easy to combine that information from different sources by using those connectors. And then that for the purpose of a design review, etc. So not just to consume the data, reference the data if it's a new build. So that's certainly quite a step forward, having all these capabilities now with this new technology. When it comes to making use of that data in a different system, we would still have to go through a conversion procedure, which then certainly requires a bit more than just running a connector. But often, what I've seen, often it's enough just to be able to reference that data in context, so I know what to do in my new plant. So that's certainly a big help, huge help actually, having those tools in place that we have right now with the digital twin.
Thanks, Patrick. And Maureen, we've had a question that's come in asking, is it feasible to build a digital twin for an existing plant? We've had a couple of questions around this theme. Thank you.
Yeah, it most certainly is. And as we mentioned during the presentation as well, you can basically start your digital twin at any phase of the asset life cycle. In fact, a lot of our users, especially in the oil and gas industry and mining, where these assets have been in operations for decades, they're seeing a significant value in building a digital twin with the information that they already have. We encourage users to use engineering models in whatever state they have. We have tools to aggregate all the information and also to align attribute data as well as geometrical data, bring everything together in one view. And in case you do not have up-to-date engineering models, you do not have CAD models, you can still start your digital twin by bringing in that visual context through a reality mesh. So using a drone, users are able to capture high resolution images of their existing facility, process them using context capture, create a reality mesh, which can then be classified to identify assets, and those assets can then be integrated with their existing operations, maintenance, and CMMS systems. And this is something that we've already done and proven on different plants that are currently in operations, and users do see a significant benefit with that.
Thank you. And Patrick, do you want to comment on that question as well?
Yes, so obviously I agree what Maureen just said, but also another level or layer, I think it's very helpful there is that once that data comes in, I can also run validation. So whether that is with the queries or we have actually a certain validation services there. So, for instance, has a tag standard been used throughout all the assets? If it's historical data, an asset or facility can have gone through different tag formats during the time, so we can run some checks there as well. And because all the data is there, and I can query that information and make use of it. So I think it's also quite helpful when it comes to make use of an existing asset in a digital twin.
Just staying with you, Patrick, for now, we've had a question that's come in from Laurie asking about, can digital models be coded to match different data structures for different project phases? By example, work may be organised by discipline or area for construction, by system, subsystem, commissioning. Thank you, Laurie, for that question.
Yeah, thanks, Laurie. Yes, we can. I mean, we have a quite an open system. So first of all, all information that has been added during the design state is going to be available in our digital twin. But we can enrich that information from other sources. We can bring in information from like an Excel sheet, etc., and combine that with a tag as an example. So there are many ways to add further intelligence to that information other than just what's coming from the design. So yeah, that would be my answer to this question.
Thank you for that, Patrick. And just on examples, we've had a question that's come in from Vinay. Good afternoon, asking, maybe Maureen, do you have examples of successful decommissioning using digital twins? Thank you.
Yes, we do. In fact, we have that example right in Australia, where the user, they were planning to decommission and shut down a refinery, and even in that scenario, they saw a benefit in creating a reality mesh, and they shared that reality mesh with one of their contractors to overlay a CAD model, because they wanted to run some analytics and generate some insights using that CAD model to help with their shutdown and decommissioning workflows. So the answer is yes.
Thank you, Maureen. Patrick, do you want to add to that answer, or has Maureen covered it off?
Even if it's in Australia, I've not been in that particular project, so I would just rely on what Maureen just said.
Thank you. Thank you. And a question I'd like to put to you both about in your presentations and Andrew presentations, we talked about digital twins being the future and clients looking for this technology. Putting a futuristic lens on this, what do you see the next 10 years is going to bring, major trends? And also, what do you see as being, drivers for change in this field? Maybe I'll start with you, Patrick.
Yeah, so that's obviously a bit a hard one to predict for the 10 years, but we can certainly see a huge increase in interest. I just had a demo again this morning. I mean, I have so many discussions around the digital twin topic with very small engineering firms or very large corporations. So this morning also is kind of the question: how do we start this journey, getting our data into the digital twin, and what are the benefits, etc. So we do kind of, or I usually do small steps there to show them what are the typical procedures, etc. What are the first kind of value adds doing these steps, etc. So I see certainly that's going to change quite a lot in the next coming years, as we see so much interest in that. And then moving forward, of course, we have to mention it, the HoloLens part and all that. I mean, it was interesting with another client in Southeast Asia, where we just started with intelligent plant design. So we just started with P&IDs and 3D models, and then we brought in the plant site level into the mix here. So they said, oh, at the beginning they were a bit reluctant, saying, wait for that, we're not ready yet. Let's focus on the P&ID, intelligent P&ID design. But then a couple of weeks later, we had another call, and then they brought in the HoloLens themselves because they got somehow that equipment and they want to make use of it. And luckily, with PlantSight, they could. So they had a very steep progress there. But yeah, I think that's certainly something as well to further avoid the necessity to go on site. Try as much as possible, maybe from the safe environment of an office, as an example.
Thanks, Patrick. Marie, do you want to add to that?
Maybe I can just add a little bit in the context of our iTwin platform. So we certainly see there is a lot of interest in the user community. They want to innovate. They want to digitize their plants and make their plants more efficient. And uh, the innovations in technology in the recent years have certainly made that possible. And over the next 10 years, we can certainly imagine that there would be more technological advances that would enable workflows that we're still considering. And one of the strengths of the iTwin platform is that it's open. It's not a closed system, so you can be assured that we'll be innovating at the pace that the technology advances. So we're always updating our platform and adding more capabilities. I certainly see, and we're also already hearing that there is a lot of interest in autonomous operations and predictive maintenance. So over the next 10 years, I certainly see that we'll have the information, the data, as well as the technology to make those a reality.
Thank you. Thank you. Exciting times ahead. Maybe making this our final question from our Engineers Australia, and for our particular young engineers. What advice would you give to young engineers coming into this area, coming to this field, as to how they, fast track their knowledge and understand and add value in this space? Patrick.
Good question. So first of all these younger people are already familiar with kind of the platform, online, and it's not new for them. So it's certainly when I compare the time I started with this new technology looks so much more exciting, maybe than the the tools I had available back in the days. So yeah, I think the innovation is certainly going to benefit largely from also younger engineers to influence the way that this is moving forward, the simplicity and everything. So my advice would be, yeah, to use the openness for young people and for us older to listen a bit also on ideas, etc. So yeah, be part of this change, I guess.
Maureen.
One advice we certainly give when we talk to new users and engineers is to always think big and prove small so that you're able to scale fast. So don't be limited by the technology that you have right now. Look at how you can make your workflows more efficient. I would say map how you're doing stuff right now. Talk to your seniors, to your supervisors to learn how they're doing things. And once you visibly see and map their user journey, you're able to identify where things can be made more efficient by either changing your work practices or applying technology. And we ask questions, especially ask questions from your data as well. We now have that data available from all these different systems coming together. So you can ask questions from that data and gain insights. So think big, ask questions, and learn.
Thank you, Marina. What a lovely way to end, to think big and move fast and move small. That is terrific. As always, we've run out of time. It's good to hear, Patrick, that we have another webinar planned that will be going into the more operational side of today's discussions. But please, Join me in thanking once again Andrew Burt, Maureen Gervais and Patri Wiki for their time and insights shared at this afternoon's session, Fast Track Your Plant Digital Twin. I'd also like to thank Engineers Australia's long-standing industry partner, Bentley Systems, for making this afternoon's webinar possible. As always, we appreciate your feedback on the program today to help us improve and plan future sessions. So if you could complete, please, the short feedback form, which is linked in the description box below. Thank you again for joining us, and we hope to see you at our next Engineers Australia Thought Leaders webinar. Good afternoon.